Hello everyone, this is Nitin, and we are Team 10, and the name of the project is Smartphone Control Data Acquisition Analysis for Advanced Sensor Systems. First of all, I would like to introduce my team to you guys. This is Shanta, this is Jeet, this is Kenneth, this is Ravi, and that's our facilitator, Dr. Wenli. Coming to the introduction of our project, as Dr. Shanta already said, it's a project sponsored by Battelle, which is an R&D organization based in Columbus, Ohio. What they plan to do is they want to take the to control advanced sensor systems using handheld devices. So they want to take it to the next level and go into the industry of the application, which is the next big thing. What we plan to do with our project is to feed in raw data using transmitters. As we don't have access to transmitters, as we don't have access to the sensors that they didn't provide us, we will be using a dummy phone to transmit raw data to a smartphone, which will then have a spectral library in there, which will try and do some Fourier transform and do some mathematical calculations to give us a final result. Basically, it works like Shazam, if you guys are familiar with it. But we have more complex data, so it's more difficult for us to do it. Coming to the background, as I already said, it's an R&D organization, and they are big on sensor development, and they work for the government. So it's not like that they don't have sensors available for them, but they're both bulky and stationary. So they just want to venture into handheld devices. So the reasons, as I already said twice, that they just want to get into handheld devices, and they also want us to research on what the future of smartphones is, what lies ahead, what capabilities do we have today, and how feasible it is to take this advanced sensor systems to the phone. For this, we have 3 project goals, which will be described by Shanta.
Hello everyone, I'm Ashanta, as Nitin mentioned, and I'll be going over the project goals. So the first project goal we have is to research smartphones. We want to know the past of smartphones, the present and the future. And so with this, we're looking at the hardware, how hardware has changed over time, and what we think it will be in the future. We're looking at software capabilities and operating systems of Windows Phone, the iPhone operating system, and the Android operating system. And we're trying to compare the different specs to see which phone would be best for us, and which would optimize the performance of the application that we're going to design for Battelle. The second project goal is to create a smartphone application. We're first going to create an application on a PC that will eventually be put on a phone, and sensor data will be transferred to a phone and compared to the libraries that's already within the cell phone. So we're going to create it on a PC, test it on a PC, make sure that everything works properly on the PC, and then from there, we're going to transfer that application onto a smartphone. And we're using Eclipse, the Java, to create the smartphone application. And then the third project goal is to create a working prototype. So once we get this on the smartphone, we want to make sure that it works. No one wants an application that's going to drain your battery power. No one wants an application that's not going to work in an efficient amount of time. So we're trying to make sure that the time to process, transmit is efficient and effective, and the application actually works effectively. We want Battelle to be pleased with the application that we give them, and we don't want it to completely drain your battery to run this one program. And so our goal is to optimize the performance of this application on a smartphone. And then with all of that, we have to make sure that we pick a smartphone that would be able to hold everything that we're doing and work effectively. So Jeet will talk about the history and the future of smartphones.
Hi, I'm Jeet. So the first smartphone was launched in 1992 by IBM, and it was called Simon. It was showcased first as a product concept in 1992, and then back in 1993 it was launched to the consumers. It had a touch screen. As you can see here, it had no physical buttons at that time. It combined features of a PDA, a mobile phone, a pager at that time, and it had a huge antenna. In 1996, Nokia Corporation launched their business optimized series of smartphones called Nokia Communicator, which was a large phone from outside, and when you opened the clamshell, it had a full QWERTY keyboard at that time. It used a processor that had 24 megahertz and 4 MB RAM. In 2002, the most commonly known smartphone today, BlackBerry, was launched, BlackBerry 850, which brought into the market push email, used mobile information services. It had all the features that current smartphone has. 2007 was the year that revolutionized the mobile world today and gave rise to a multi-billion-dollar business called the App Store, because of which we are doing the project today, and it was iPhone. So the current smartphone situation. You might be thinking, why am I using the smartphone today? We are just using the potential of the smartphone to control our presentation. So the current smartphone, if you see, we compared 4 Android phones and 1 iPhone. All of them have nearly the same specifications, like 1 GHz processor, 512 MB RAM. And the data storage varies. Some have internal memory, some have external memory. So the future of smartphones. Taking advantage of the embedded physical sensors available today and the data capabilities, the new line of smartphones will be context aware. So what it means is it's automatically going to switch profiles when you enter a restaurant. If you sit on a driver's seat in a car, it's going to change profiles, so you don't need to worry about making it to silent mode or anything. Another good use of the physical sensors would be the NFC chips, the near field communication chips, because of which your smartphone is going to be the next credit card, your identity card, even your passport. It's just that the biggest challenge right now for the NFC chips to be used is that security reasons. If your smartphone is lost, you lost your visa, you lost everything. And recently Motorola announced their 4G phone Atrix, which comes with an accessory that is a laptop dock. What it does is it utilizes the processor of your smartphone and the memory of your smartphone and just converts it into a netbook. So as such, it is a it has a dual core processor, and it's going to replace the current netbooks too. I'll hand it to Kenneth for current sensor system improvement.
Hi, I'm Kenneth. This is a spectrometer Altair is using at the moment. They are seeking to remove the processing unit from the sensor system and place a smart sign on an analytical instrument such as smartphone, so that they can integrate the whole system for the future application. As you can see in the picture, a processing unit takes about a quarter of the overall system size. And the power consumption is pretty high because all the computation is actually taking place in the system. So removing the processing unit from the sensor system will definitely reduce the size and as well as the power consumption, making the sensor system much more suitable for the handheld device in the future. This is our conceptual design for a project based on Altair's specification and the expectation for the future application. The sensor system, or specifically infrared spectrometer, will be pretty much the same component-wise, except the processing unit will be removed, of course. It will only collect the data of the chemical compounds, also known as the interferograms, and transmit the interferograms to a phone upon receiving a request from the user. The smartphone, on the other end, will receive this data or interferograms from the dummy sensor system by sending out a request signal. After the data reception has been confirmed, you will start processing the data, which in our case is applying infrared spectroscopy for a transform on these interferograms to generate a result spectrum. And then the smartphone will compare this result spectrum to a pre-populated spectral library, and the user will be notified of any matches. Since the smartphone will assume the role of an analytical instrument in Altair's future plan, its operating system must be powerful enough to handle the task of data acquisition and complex computation. Right now, there are currently 3 major smartphone operating systems available on the market. They are iPhone operating system, Android, and Windows. We rule out Windows because it doesn't support multitasking, which is the ability to run third-party applications without slowing down the system. And it doesn't have a large share of the market. So we have narrowed down our scope to only Android operating system and iOS. But it's still hard to make a decision. Between these two because they are all very competitive in terms of what we need. Eventually, after some research, we decide to focus on utilizing Android operating system over iOS for the following reasons. First of all, Android operating system, as you may know, is open source software. Secondly, the software development kit for Android is available online and it's free. And Android operating system has a predominant share of the market at the moment. But the major reason why we choose Android operating system is that there are currently over 30 models of smartphones running Android operating system. Although one may argue that iOS provides uniformity across all iPhone devices, making the testing conditions much more controllable for a project that's essentially proof of concept in nature, we hold a different opinion against that. We should view that uniformity as an disadvantage, since there's no room for improvement performance-wise. And thus the result is always the same, while the performance of the Android operating system varies from phone to phone. So potentially, if we choose the right device, the performance can be optimized. And that's why we choose Android operating system over iOS. And so, of all the 4 Android phones that G just briefly went through, we are going for Google Nexus S. As you may see in the table, they are pretty much similar spec-wise. Even though Nexus S is the only Android phone that doesn't support external memory, and internal storage of 16 gigabytes is just more than enough for our project testing. Besides, it's the only Android phone that has the most recent version of the operating system. Therefore, we choose this one as our analytical instrument for our project design. Next, Robbie is going to go over our approach, our final design solution, risk, and the budget.